In today's video, I'm going to introduce you to Excel's Solver tool and show you simple ways on how you can benefit from it. I'm going to show you how you can use Excel's Solver to solve for more complex problems that GoalSeek can't solve for. Why? Because GoalSeek is just restricted to changing one single input variable. So this is the example that we looked at in the previous video. What we had were the units sold, price per unit, we calculated the revenue, then we had the cost per unit, the cost, and then we calculated the income. That's just revenue minus costs. We use GoalSeek to find out how many units we need to sell to get a specific income. So if I go to GoalSeek, that's under Data What If Analysis. It's really simple to use. It allows you to set your calculated cell to a specific value without changing your formula by changing an input cell. So you can see here that you're just restricted to selecting one single cell. But what if you didn't want that? What if you wanted to change two things or three things? And what if you wanted to add constraints to this? You wanted to say, well, units sold, they can't be decimal places, they have to be full numbers. Price per unit can't go above $4, and cost per unit must be below this number. If you want to add any constraints to this, and if you have more than one variable, that's when you need to use Solver. Solver is by default not activated when you install Excel. It's there, it's just not activated. Now you can see that's my Solver here, I've activated it. If you don't see yours here on the Data tab, it means that you need to go and activate it. To do that, all you have to do is go to File, Options, Add-ins, and down here you go to Manage Excel Add-ins, just press Go, and this is where you need to put a tick mark, right? So yours is not going to have a tick mark. Put a tick mark and press OK, and you get to see it here. Okay, so now let's take a look at how this works. Solver is a very powerful tool. It can do complex statistical modeling. So calling it an advanced GoalSeek is not doing it much justice, but the thing is that a lot of people avoid Solver because they think it's very complex and it's meant for complex problems, which it is, but it can also very quickly solve your simpler problems. For our example here, let's say we want to set objectives, so that's our income. We want to set this to a value of 2000. Okay, now you can see you have different options here. You could say, give me the maximum number that this value could be, that the income could be, given these constraints that you can put in here. Or give me the minimum cost that I could have given the constraints that you put here. But for our example, I'm going to go with a value of 2000. Which cells do we want to change? Well, I want to change these two, because all you have to do is highlight them. Now I also want to change this one, so I'm going to put the Excel separator and then click on this. So now Solver knows it has to change these ones to get to this. If I don't give it any constraints right now, let's see what Solver gives us. I'm going to leave everything as is and press Solve. Okay, it says Solver found a solution, and the solution you can see right here. So I put this to 706, 4.26, and 1.43. Okay, I say, well, no, I want to give it some constraints because I cannot sell at a price that's above 4. I'm going to do cancel and go back to Solver. Okay, so everything else is still there. Now I'm going to add a constraint. My first constraint is units sold. I want them to be an integer, right? I don't want them to have any decimals. Okay, so that's one thing I'm going to add. The next constraint that I want to add is that price per unit, that must be less than or equal to 4. Here I can either use a cell reference for it, or I can type the number in manually. In this case, I'm going to add it in manually. I could add another constraint for cost as well. I could also expand on this same constraint and say it has to be less than or equal to 4, but greater than and equal to 3. I can add that by just going here, saying add, and putting this again in here, and selecting the greater than and equal to and 3 here. Okay, so we go back and let's take a look at our constraints. So the first one is an integer. This one has to be between 3 and 4. Let's solve for this. And that's our result here. And we get to 2000. That's a very quick way of using Solver. You can add in more constraints and you can change your solving method. But for these type of simpler problems, you really don't need to worry about this. This is basically the different methods that Solver can use to solve your problem. The first one is generalized reduced gradient, and the last one, evolutionary. They're both for nonlinear cases. Simplex LP is for linear relationships. So if you're sure that you have a linear one, you can use simplex. If you don't, it's much faster if you use the GRG. GRG tries to find a local optimal solution and evolutionary a global optimal solution. So it takes a lot longer to run than the first one. And if you do use evolutionary, you do need to define the upper and lower bounds of your variables here. But in most cases, you're just going to be fine with GRG nonlinear. Once you press solve, if you like the answer that Solver gives you, you can press OK and it takes it over. Obviously, it doesn't touch any of your formulas. Nothing is changed. The only thing that's changed are your input values. You can see that's a full number, and this is according to the constraints that I defined. That's a very simple example of using Solver. So just to give you another idea of Solver, let's take a quick look at this exercise. The aim of the exercise is that we have a budget that's given to us for these projects, and we want to allocate it between all of these given special constraints that are defined here. So let's say I originally did the planning of this. I put in the production cost associated with each project, the fixed cost, the extra cost, and I came to this number. And I'm told, okay, you have this budget, use this budget, but these are my constraints. The extra cost shouldn't exceed 1,000. My fixed costs need to remain at 2,000, and the total cost for each project shouldn't exceed 9,600. These are my constraints, and given that I need to change these numbers, so my outcome is this number. Let's quickly use Solver to get the answer. The total cost here, that's this cell, it should be 65,000. Which cells can be changed to get to this result? So let's take a look at our constraints. Extra costs should not exceed. That's something that I can change. So I'm going to add that here. The other thing I want to change is fixed costs need to remain at this, but they're already all 2,000, so I don't need to add it here. And total project costs shouldn't exceed 9,600. So total project costs are these, but these are calculated. I need to be able to change the input. And the main input for them is the production cost here. So that's something I can change, but the constraint is not on this. The constraint is going to be on the total cost here. So let's add the constraints. First constraint is that extra costs, they need to be less than or equal to 1,000. So now I'm going to do a cell reference here. Next one is that the total costs here, they need to be less than or equal to this number. That's it. Let's solve for this problem. Solver found a solution, and let's just go take a look at it. 65,000. This is nowhere close to 1,000. That's fine. And the total cost does not exceed 9,600. So I'm happy with this. I'm going to accept the new input values. So this is how you can use Solver to solve for complex what-if analysis that GoalSeek can't solve for. Thank you for watching. If you like this video and you learned something new, don't forget to give it a thumbs up. And for more Excel videos like this one, why not subscribe to this channel so that you can get updates when new videos come out.